I am Homo sapiens. Do you know how our solar system was formed? The formation of our solar system is a wonderful event that occurred billions of years ago. By understanding the laws of physics and cosmic events, we can understand the existence of the sun, planets, moons, and countless smaller celestial bodies. The process by which clouds of gas and dust transformed into a solar system not only provides insights into the origin of our solar system but also helps understand the origins of other planetary systems in the universe. Nebular hypothesis. The most widely accepted model for the formation of the solar system is the nebular hypothesis. Proposed in the 18th century by Immanuel Kant and Pierre-Simon Laplace, this theory suggests that the solar system formed from a giant cloud of gas and dust known as the solar nebula. According to the nebular hypothesis, a long time ago, there was a massive star whose fuel was running out. As its fuel dwindled, the star's gravitational force began pulling its surface inward. Eventually, the star's fuel became so depleted that the gravitational force generated by the star's mass successfully pulled all its mass towards the center. In less than a second, the massive star shrank rapidly and then exploded with a tremendous force, an event known as a supernova. The supernova explosion produced heavy elements like oxygen, sulfur, carbon, iron, and silicon, along with radioactive elements. These elements were scattered over a vast area, forming a nebula. This was the solar nebula. About 4.6 billion years ago, some disturbance in the solar nebula led to the formation of a center. This disturbance could have been initiated by gravitational waves from a nearby supernova, triggering the process in the cloud of dust and gas in the nebula. As the nebula contracted, its increasingly dense center began spinning rapidly. Most of its mass accumulated in this center, forming a protostar, the early form of our Sun. The remaining cosmic dust and gas cloud spread out into a rotating disk around the protostar, known as a protoplanetary disk. This disk is where planets, moons, asteroids, and comets were formed. In the protoplanetary disk, dust and ice particles began colliding and sticking together, forming larger and larger clusters. This process led to the formation of planets. Near the protostar, rocky planets such as Mercury, Venus, Earth, and Mars were formed. Farther from the protostar, gaseous planets like Jupiter and Saturn, and icy planets like Uranus and Neptune were formed. As the protostar continued to contract and heat up, nuclear fusion eventually began. The onset of fusion transformed the protostar into a star, our Sun. Formation of the Moon. About 4.5 billion years ago, in the early stages of the solar system's formation, a Mars-sized planet named Theia collided with Earth. This collision was extremely violent and intense, melting large parts of both Earth and Theia and ejecting debris into space. This debris spread around Earth, forming a disk under Earth's gravitational influence. Over time, this debris coalesced into a large body, which became our Moon. Initially, the Moon was in a molten state. Gradually, its surface cooled, forming a solid crust. This process took millions of years, eventually resulting in the Moon's current form. Initially, the Moon was closer to Earth, and Earth rotated faster, making days shorter. The Sun was also less bright compared to today.